So Newmann projections. Things that people get confused on, I think, is there's only really 4 types. There's these 4 types, really. Both eclipse pointed down, eclipse pointed up, staggered 1 down, 1 up, staggered 1 up, 1 down. And if you number these carbons, like right, if you're like looking down 1 to 2 each time, you can kind of get a feel for what this would look like, right? If there's a person, if you're always looking down 1 to 2. So how does this actually translate to the Newmann projections themselves? Right, so for the first one, it would be down and down. For the second one, it would be up and up. Down and up and down. Now, because I knew that this is because this is carbon 1, this is carbon 2, 1, 2, 1, 2, 1, and 2. Right, you'll notice here, if I'm looking, right, the person's looking down 1 feet, 2 feet, 1 head, 2 head. Here, if I'm looking, 1 at my feet and farther back at my head, feet. And then you got to fill everything else in, right? So you still have your wedges and your dashes, right? Wedge and the dash are always right next to each other. Wedge and dash are always right next to each other. There, 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 and there. Right, so it does matter, right? These are the 4, basically the 4 types that you can have. So it does matter which one you pick, depending on which one you're starting with, if that makes more sense, right? Either could be eclipsed down, eclipsed up. Staggered, up, down, staggered, down, up. And if you're looking in that direction, that's the way things will go. So then if we're thinking about rotations for this, let's just do one of them. If we're going to do 60 degrees, let's do counterclockwise, 60 degrees. Let's move carbon 2. So if we do that, what doesn't need to change is anything with carbon 1. Right? Carbon 1 just stays the same. That's the first thing people should do. Oops. So carbon 1 stays exactly the same. If I'm going to rotate carbon 2 counterclockwise means to the left, right? That's counterclockwise. 60 degrees means I'm going to go from this staggered conformation to an from an eclipse conformation to a staggered. So let's say if this was square, X, and circle is now here. It went 60 degrees, that's right in this spot. Square went 60 degrees, so right there, and then star is right here. All right, the key is remembering 1 and 2, which carbon stays still and which one rotates. Okay, so let's say you have something like this, and you have a wedge and dash structure, and you need to turn this into a chair. You need to turn it into the most stable chair conformation. So the way to do this would be to write both chair conformations, really. So to do that, I'm just going to start by drawing out my chairs. Then I'm going to number things. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Note, I put this as 1. I pull it down, right, on the flip. On the flip, 1 goes down here. 1 pulls down. 1's there. 4 gets pulled up. 4 is there. All right. Then I'm going to go up here and do the same numbering. It doesn't matter actually how I want to number it. I'm going to do it this way. 1, 2, 3, 4, 5, 6. I consider wedged, when I do this, I consider wedged up dashed down. That's how I'm gonna do it. And so now I need to look at carbon 1. And carbon 1 needs the OH up, and that is an axial position here. Carbon 3 needs fluorine up. That's an axial position here. And carbon 5 is this big group, and that's down, so that's equatorial. All right, so hopefully people can see how I got there. Remember, every time you do a chair, every time you have one of these, you have two different types of chairs, right? So on carbon 1, I say this is up. That's the direction. The direction never changes on a chair or on a ring. It's up. I can draw it up axial. I can draw one chair where it's up axial. I can draw another chair where it's up equatorial, right? I'm going to have to do both. So here, the first chair I drew, I put at this carbon 1, that's axial up, 2, 3. At carbon 3, the up position is axial. On carbon 5, the down position is equatorial. So now what's going to happen on the other side when I do the ring flip, OH is going to be up but equatorial. Fluorine is going to be up but equatorial as well. And now the large carbon group is going to be on carbon 5 and axial down. All right, so these are the two types of chair. Every one of these has two types of chairs it'll always have. So then the question of which is more stable, it's actually, I mean, this is a tough one. I don't know, I just made this up. Actually, I would probably guess this is the most stable one because this is a really big group. It's called the torpedo group. You wouldn't know that yet, but that's a really large group. It has, there's 3 hydrogens on each of these. There's 9 hydrogens, 4 carbons. It's pretty big. So I would guess this would be the most stable one because the largest group's equatorial. That's the key. Having the largest set of atoms or atoms equatorial.